So good evening everyone. So our topic is about time series regression. So the reporters are the following: Velasco, Igot, Potot, Singco, Tariman, and Tatud.
So understanding time series data. So time series data is a unique and essential component of our discussion. So it refers to a sequence or observation or data points collected to equally spaced interval over time. So these data points are ordered chronologically and their temporal relationship and fundamental in time series analysis. So, importance of time series data. So, pattern recognition. Two is prediction, and last is casual analysis. So, kini, key characteristic of timers series data. So, temporal order, time series data is always ordered in a chronological sequence. The order of data points matters, and they are typically collected in equally spaced intervals such as hourly, daily, and yearly. Second is regular intervals. Data points are collected at regular, fixed interval. This regularity enables us to identify and analyze trends, seasonal, and other patterns of overtime. So last is temporal patterns. So time series data often exhibits various temporal patterns including trends, seasonality, cycles, and irregular fluctuations. So thank you.
So next is we will tackle what is time series regression. So time series regression is a statistical technique used for modeling and analyzing data collected or observed over time at equally spaced intervals. So it provides a framework to understand how changes in predictor variables influence the behavior of a time series. So in this approach, the focus is on how is on understanding the changes or how changes in predictor variables impact the behavior of a time series. So where observations are recorded at regular intervals. So this technique is particularly useful for predicting future values or identifying patterns or trends in time dependent data. And next is key components of time series regression. So dependent variable. So this represents the variable we aim to model or predict, and it's the outcome variable that changes over time and depends on other factors. So mo siya ang main variable of interest in a time series regression. So mo niya siya ang atong i-try to model or predict and is kanang observe over time at different nga intervals. So next is predictor variable. So these are the independent variables that might influence the dependent variable. So in simple regression, there's typically one predictor, but in multiple regression, there can be multiple predictors. And mo siya ang independent variables that are believed na kanang na-influence sa dependent variable. And in time series regression, these variables are observed or measured at the same time points sa dependent nga variable. So next is intercept and coefficients. So these are parameters of the regression equation. So beta 0 is the intercept and beta 1, beta 2, etc. are coefficients representing the relationship between predictor variables and the dependent variables. So ang intercept ay nag-represent ni siya sa expected value of dependent variable when all predictor variables are zero, while ang coefficients represents the strength and direction sa relationship between sa predictor variable o dependent nga variable. And lastly is error term. So the error term accounts for unexplained variations in the dependent variable. So it represents the difference between the actual observed value and the predicted value. So ang error terms man siya ang crucial component in statistics models, particularly in regression analysis. So next slide. So applications of time series regression. So first is finance. So time series regression is widely used in finance to kanang analyze and predict sa iyang stock prices, kanang market trends and other and economic nga indicators. So next is economics. So economists use time series regression kanang to study economic indicators such as GDP, kanang inflation rates, and kanang employment trends. Third is meteorology. So in meteorology, time series regression is applied to uh, analyze weather patterns, predict future conditions, and understand the impact of various factors on kanang climate nga variables. Next is healthcare. So time series regression is employed in healthcare for predicting patient outcomes and analyzing sa effectiveness of treatments over time and studying trends in public health nga data. And lastly is manufacturing and quality control. So in manufacturing, time series regression is used to monitor and control product quality over time. So it helps kanang identify patterns and factors influencing production processes, enabling adjustments to improve sa efficiency and sa ang product nga quality. So challenges and objectives sa time series regression. So while time series regression offers valuable insights, it comes with its own set of challenges, including autocorrelation. So ang autocorrelation is the presence of so ang presence of autocorrelation is where a variable is correlated with its past values and can complicate the analysis and interpretation of time series data. And next is seasonality detection. So ang seasonality detection is kanang identifying and accounting for seasonal patterns in the data is kanang crucial for kanang accurate nga modeling, as certain variables may exhibit regular fluctuations at specific times of the year. And next is dealing with missing data. So time series data often contains gaps or kanang missing values which pose kanang challenges in maintaining kanang the continuity of the analysis. And kanang strategies for kanang handling sa inani nga missing data are essential for accurate results. And next is the primary objectives of time series regression are prediction. So prediction, ang aim is to forecast kanang ilang future values sa dependent variable based on historical data and the relationship between sa predictor nga variable and causal analysis. So it seeks to understand and quantify the causal relationships between variables, helping the researchers and analysts identify the factors that influence the observed trends and pattern detection. So time series regression is used to uncover underlying patterns and or trends in data, providing insights into behavior or making informed na decisions and implementing effective na strategies. So next slide.
Okay, so the next one is assumptions of time series regression. In this area, when we use time series regression effectively, we make several important assumptions. The first one is linearity. We assume that relationship between the dependent and predictor variables is linear. So in other words, in a change in the predictor variable results in a proportional change in the dependent variable. So meaning linearity implies the relationship between what you're trying to predict. So what you're using to make predictions. So should be like a straight line. So if you plot the data on a graph, it should roughly follow a straight line. So these assumptions allows us to make predictions based on consistent pattern or trend in the data. So the second one is independence. Independence. So we assume that observations are independent of each other. So each data point is not influenced by previous or future data point. So meaning independence kay kanang kuan siya, each data point is not influenced by one's around it. So, in a time series context, it implies today's value or event is not affected by what happened yesterday or what will happen tomorrow. So, each piece of data is treated as a separate and then a related observations, and also to ensuring that the analysis doesn't mistakenly assume patterns that aren't there. So, mana siya independent. So, stationary. So, we assume that the statistical properties of time series data do not change over time. So, this includes consistent mean, variance, and autocorrelation. In this area, stationary is a bit like constancy over time. So it means that the statistical characteristic of your data, like the average value, then spread values, and the relationship between values will remain relatively constant. So this is crucial because many statistical methods assume that the underlying structure of your data doesn't change over time. So if your data is stationary, you might need to transform it to make the analysis more accurate. So man siya is stationary. So the last one is no autocorrelation. So we assume that residuals or the difference between the observed and predicted values are not correlated with their past values. So in the other words, there is no systematic pattern left in the residuals after fitting the model. So in autocorrelations, it is about the independence of predictions, errors over time. So when you make a prediction using a model, there's often a difference between when you predicted and what actually happened. So autocorrelations BI checks whether these prediction errors are related to each other. So if there's pattern in these errors, like consistently underestimating or overestimating, so that suggests there's more information to be captured with the model. So, meaning these assumptions are like set of rules so that to ensure the reliability and accuracy of your predictions. So, they might how you should be analyze your time series data, making sure your model doesn't mistakenly find patterns that aren't real or make predictions based on flawed assumptions. So, following these assumptions helps make your statistical analysis is more trustworthy for understanding and predicting real world phenomena. And now let's proceed to testing assumptions. So unsa dining testing assumptions? So to validate these assumptions, several techniques and tests can be employed. So there are 4 aspects of testing assumptions. So first is visual inspection. So When we say visual inspection, so examine plots for the time series data for detect non-linearity, trends, or seasonality, and also visual inspection can reveal patterns that might violate the linearity and stationarity assumption. So example na kanang magplot ka og monthly sales over time. So ana siya. So plots helps identify patterns that might violate linearity. So meaning that non-linear trends or seasonality may suggest need for additional model consideration. So when you're plotting your monthly sales, so if there's clear upward or downward trend or repeating patterns indicating seasonality, so it suggests non-linearity or seasonality in the data. So possibly the violating the assumptions. So now let's proceed to the second one is autocorrelation function or ACF. So the ACF plot can help assess autocorrelation. So if there are significant autocorrelations in the residuals various lag, it suggests a violation of independence and no autocorrelation assumption. So pasabot ani, so ang purpose ani siya kay mo-assist siya og autocorrelation in residuals. So significant autocorrelations at various lags indicate a violation of independence and no autocorrelation assumption. So NACF plots help identify potential issues with the residual temporal. So example na mag-calculate and plotting ka og mga autocorrelation nga nag-relate sa residuals. So if there's a significant correlation at various lags, it implies temporal dependence and residuals violating the assumption of independence. And the third one is augmented decay Fowler. So Fowler test or ADF. So this statistical test is used to check for stationary in the time series data. So if the p-value from the ADF test is less than a significance level, indicates that significance level example is 0.05 if there is no given in the data. So indicates that the data is stationary. So in this area, so ang purpose niya is kana mo check siya og stationary in time series data. So a low p-value or kining sample is sample is kita og less than 0.0 man siya ang significance. So suggest that the data is stationary. So supporting the stationary assumption. So non-stationary data can affect the model's performance and stationarity is often prerequisite for accurate regression analysis. So example is applying the ADF test to check for stationarity. So kana siya. So the last one is residual as analysis. So careful examination of the residuals can provide insight into violation of assumptions. So residual plots such as scatter plots of residuals versus predicted values should exhibit random patterns without any trends or structures. So meaning residual is the examined residual for violation of assumption. So mara siya purpose sa residual analysis. So residual plots such as scatter plots or residual versus predicted values should display random pattern without trends or structures. So mara siya ang systematic patterns may indicate that the model fails to capture certain aspects, so leading to violation for regression assumptions. So example na when you're creating plots or residuals versus predicted cells. So mana siya. So in these four categories, so it might be employing the techniques. Analysis can assist the validity of assumptions crucial from series regression in enhancing reliability and interpretability of the model.
Next is benefits of time series regression. So, time series regression offers several advantages, including predictive modeling. So, it enables us to forecast future values of the dependent variable based on historical data and predictor variables. So, ang time series regression is a kanang powerful tool for kanang predicting future values of a dependent variable by kanang analyzing sa iyang historical data and interpreting sa iyang predictor nga variables. So next is causal analysis. So it helps us understand how changes in predictor variable impact the dependent variable and making it valuable for identifying cause and effect relationships. So it aids in kanang comprehending cause and effect relationships by examining the correlation between predictor and dependent variables over time. So thereby, so revealing causal connections and system nga dynamics. So next is trend analysis. So time series regression can be used to detect and model trends whether they are upward, downward, or flat. So it helps identify and kanang model data trends, recognizing direction and magnitude of changes over time, and providing valuable information for kanang decision making. And lastly is seasonality analysis. So it allows for capturing cyclical patterns that occur at regular intervals such as daily, monthly, or yearly seasonality. So this model capture and ang time series regression models capture and model cyclical patterns at kanang regular nga interval. So it improves accuracy in predicting future values and understanding recurring behaviors or events. So mo to siya.
The next topics will be the types of the time series regression. So, time series regressions come from several forms of it, including the simple linear time series regression, multiple linear time series regression, time series autoregression, time series moving average, autoregressive integrated moving average, and seasonal decomposition of time series. So first, we're talking about the simple linear time series. This involves a single predictor, a variable in a line relationship between predictor and in the dependent variables. So, a simple linear time series regression is a statistical technique that is used to model relationship between two variables over the time. So these two variables are referred to as the dependent variable, where the variable are typing predict, and the independent variable, where the variable that we think is influencing the dependent variable. So in simple, linear time series regression is the dependent variable is a single predictor variable, and the relationship between two variables is shown to be linear. So this means that the dependent variable is assumed to increase or decrease linearly with the independent variable. So I'll give you an example. So let's say that we are interested in predicting the monthly sales of product based on the amount on advertising spent that month. So we can all use simple linear regression to model this relationship. So the dependent variable indicates that we would be the monthly sales of the product, and the dependent variable would be the amount in the advertising spent that month. Uh, so we would assume that it's linear relationship between two variables, which means that we would assume that the monthly sales of the product increase as the amount of advertising spends increases. So in in all that, in a simple explanation, the simpler regression is a useful technique for modeling relationship between two variables in over time. However, it is important to be aware of the limitation of the techniques before using it. So next is the multi-linear time series regression. So it extends the simple model of including multiple predictors variables. So multiple linear time series regression is a regression model that is used to model relationship between dependent variable and multi-independent variables that the independent variables are set of variables that are thought of to influence the dependent variable. So the dependent variable is a variable that we are trying to predict. That's what I said earlier. So in multiple linear segregation is the dependent variables are also assumed to be time dependent. So this means that the relationship between dependent variable and the independent variables can be changed over the time. So next regression is the time series regression time series autoregression. So autoregression model is a linear regression model in which the dependent variable is regressed in its own lag values. So that means that the current value of the dependent variable is regressed and on its value from 1 or 2, 3 and more at a time in periods in the past. So the number of the lags values are included in the model as they are called the order of the model. For example, an autoregressive model is a model that includes one lag value on the dependent variable, and two, a regressive zoo model is a model technique that includes two lag values in the dependent variable. So models autoregression and regression are simple and easy to use technique for modeling time series data that exhibits autocorrelation. But however, it is important to be aware of the limitation of the technique before using it. The next is the time series moving average. These models use lag values of the error terms as predictor variables in addressing short-term dependencies. So time series moving average is a linear regression model in which dependent variable is received on its own log error terms. Unlike in a what do you call this autoregress autoregression time series. Sorry. So this means that the current value of the different variable is regressed on its error terms from 1 to 3 and more at a time. So period in the past. So the number of log error terms are included in the model called so same as the order of the model. So and all that ng moving average is a simple and easy to use for time series and a short-term dependencies. But however, it is more important to be aware of the limitation also before using it. So 5 is the auto-regressive integrated moving average. So it is a class statistical model used for forecast time series. These models are most commonly used for casting non-stationary time series data, which is the data whose statistical properties, such as mean, variance, change over at a time. So it has the three combined different types of models, which is the auto-regressive models, integrated models, and moving average models. So these models are more powerful tool for casting non-series data. So the number of limitation, they have a number of limitations. Sorry, the one limitation is they assume that the relationship between dependent variable and its values is linear. So this may not always be the case. So if the different and the relationship is not linear, so then the model will not be a good fit for data. So another limitation of uh, auto-regression and the gradient moving average is that they not take into account for that to that data that may time independent. So this means the models may not be able to capture trend data over at a time. So lastly, the sectional decompositions of time series. So it decomposes time series into trend, sectionally, and residual components for analysis. Wait. So this time series is a statistical technique that breaks down at a time series into three components, which is three trend. I mean trend, seasonal and residual. So it is very useful technique for identifying and analyzing pattern in a time series. That this method it decomposes time series in three components. Okay. Uh, so seasonal time and seasonal decomposition of time series is powerful tool for analyzing series data. It can be used to analyze trends and as seasonal patterns in the data. So it is relatively simple technique to use and understand, and it could be very effective for forecasting futures and time series. So the next topic will is next, Jan. So the next topic will be the model selection. So first is choosing the appropriate time series regression is model. It depends on the characteristics of data. So model selections may require first is the visual inspection of data to identify patterns and trends. Second is a statistical test and for stationarity to assess data's properties. Third is autocorrelation function, so ASF, and a partial autocorrelation function, so PASF, CF. So plots to identify the order of auto-regressive and moving average terms. And last is cross validation techniques for model evaluation and validation. So first, we're talking about the visual inspection of data to identify patterns and trends. So visual data inspection of data is a crucial step in time series analysis. So as it is allows us to identify patterns and trends, so that can inform subsequently modeling steps. So this process involves plotting the data over time, examining the shapes of the series, and looking for many irregularities and anomalies by studying data visually. So we can gain insight into the underlying dynamics of the time series and identify the potential issues that may require further investigation. So next is the statistical test for stationarity to assess the data properties. So it is stationarity is a fundamental property of time series data that implies that the statistical properties of the series it is such as the means, variance, autocorrelations that that do not change over time. So before proceeding with the time series modeling, so it's essential to assess whether the data is stationary or not. So several statistics tests exist for this purpose, including the augmented Dickey Fowler the test and the Kwiatkowski Phillips Smith Shin or the KPPS test too. So this test provides statistical basis for determining whether the time series exhibits or random walk or a trend, which has implication for the choice of modeling approach. So third is the autocorrelation function and partial autocorrelation function. So let's to identify the order of autoregressive and moving terms. So this autocorrelation function and the autocorrelation function are the graphical tools that used to identify the order of autoregressive and moving average terms in an autoregressive integrated moving average or ARIMA model. So the ACF, where the autocorrelation function measures that the correlation between the time series and its logs values, while the PACF, where the partial autocorrelation function measures that the between the time series logs after the controlling for the correlations within intervening log values by examining the ESF and the ASF plots. So we can determine the number of AR and MA terms that are more likely to be present in the model. So the last is cross-validation techniques for model evaluation and validation. So cross-validation is a method to use that assess the performance of a time series model by dividing the data into training and testing test sets. So this model is trained on the training set and its performance is valued on a testing set. So this process is also repeated multiple times using different combinations of training and testing sets and the average performance across all folds is used to estimate the model's generalizability. So common cross-validation techniques include k-fold cross-validation and leave one out cross-validation. Next.
So the next is the formula for simple linear time series regression. So ang formula ng simple linear time series regression is y underscore t is equal to b0 minus b1 times x underscore t plus e underscore t. Paliwan next. So let's break down each component of this equation. So first is the y underscore t. So ang y underscore t is the dependent variable at time which represents the value we are trying to model, predict, or understand. So in time series analysis, this could be stock price, temperature reading, sales figure, or any other variable of interest. So next is x underscore t or is the predictor variable at time. This variable represents an independent factor that we believe affects or influences the dependent variable yt in a simple linear regression. There's only one predict. So note then is usara ka there is only one predictor variable. So next is B0. This is the intercept term representing the value of y underscore t when when the when x underscore t is equal to 0. So it's the starting point of the regression line. So bali ang B0 is starting point daw of the regression line. So ang the fourth is B1. So B1 is the coefficient of the predictor variable x underscore t. It signifies the change in the dependent variable, which is the y underscore t, for a in 1 unit change in x underscore t. It quantifies the strength and direction of the relationship between x underscore t and y underscore t. And then the fifth is e underscore t, or the error term at time. It accounts for the explained variations of y underscore t that cannot be attributed to x underscore t. In other words, it represents the difference between the actual observed value of y underscore t and the value predicted by the regression model. Taligo next. So, ang B0, or the intercept, indicates the expected value for the of the independent variable when the predictor value is 0. And then the B1 is the coefficient that quantifies the effect of a 1 unit change in the predictor variable on the dependent variable. The positive value of B1 suggests a positive relationship. So while negative value suggests ang negative nga value is suggests a negative relationship. Go next. So, the use cases of simple linear time series regression. So, simple linear time series regression is applied in various scenarios. So, the first is trend analysis. It helps in identifying and modeling trends, providing insights into the direction and magnitude of changes in time. So, ang trends represent long-term changes in the series that can be provide insights into the direction and magnitude of these changes. So the second one is causal relationships. So it's used to determine if there's a cause and effect relationship between the predictor variable and the dependent variable. So the third one is baseline models. Simple linear regressions serves as a fundamental building block for more complex time series regression models such as ARIMA and multiple regression. So ang baseline models is nag-serve niya siya as a starting point for more complex analysis. Next.
Okay. So, good evening, everyone. So, my part is all about the example and problems. So, my colleagues or co-reporters discussed about the theories about the time series regression, what is time series data, and about the regression. So, basically, there are many parts on how to solve the time series. There are some variants, especially with the regression model. There are some parts of how to solve the times, but within this some sample problem, this is about the linear regression or the simple linear regression model when it comes to solving time series data. So also, the other reporter or last reporter said that time series is technically useful for projecting or projections, useful in business or for forecasting. So this problem is about a forecasting sales. So these are the sample data, which is week 1, 2, 3, 4, 5, with each sales for each week. So first, we must identify, of course, what is the dependent variables and the independent variable. So we have it here week as the independent variable, and the sales. Of course, sales is dependent for what we so sales would be the dependent variable. So second step would be plotting so that we can see if this is the regression line or this is the line that does fit, because that is the another term for regression, which is focusing on the best line fit. So to graph it or to have it visualized with regarding to the line, so we must uh, also plot the data points. So using the x and y axis, we do have for the y axis for the sales and t or x axis for the t or our week. So by plotting, so you can have it here 1, 2, 3, 4, 5 in the x axis, having the week 1, 2, 3, 4, 5, plotting the sales from ranging from 25, 50. So this is for the sample sales. So plotting week 1 have 150, so point must be week 2 has a 157, so around within this area. So it's just plotted in here. Week next would be the third week, which is 162, so still on this area. And then week 4, 166 on this area, so on and so forth. So usually once we connect the data points, so this is the regression line, or we can say the stock line. So next, next sales for the next weeks. So since this is the given only until week 5, so for us to predict, so let's use this formula, the y equals a plus b plus t or time. So that is just also x plus b, or to formulate this one, this is also some example of the linear regression. So in order to find a, because well, we don't have the, or our a value here is unknown, so we must have a formula. So formula for finding a, that is summation or sigma y, summation of y minus b summation of e over n, and then we must also find minus summation of t times summation of y over n summation of t squared minus e summation t squared. So that will be the formula. And to expand from this, so we must find its summation as well. So summation of dy, summation of t, summation of y, summation of t squared, and summation of et squared. So to have this visual and to have us easy to perform as well, and to have a guide from what we are doing, so we must plot it via table or through table. So this is the example table. So we plot here for example, lately we graph the line or we graph the data points from week 1 to 5, and then the sales or the y. So for this one, we must find p, or we must do another uh, table for us to compute for those missing needed for the formula. So this one is for the t squared. So 1 squared, 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, so on and so forth. And for the ty, so this is for 1 times 150, 150, 4 times 157, 314, so on and so forth. So summation for this one, summation of t. So we must just add this 1 plus 2 plus 3 plus 4 plus 5. So we come up with 15. So summation of t squared. So this will be add on for this table. And then summation of y. Also add this data and also summation of ty. So we do have here um, the missing data or information that we need to have it plot for our values of A and values for B. So we have E summation T, which is on. We have also summation of Y on, summation of Ty, and summation of ET squared. So for us, so we must plot. So following again the formula y equals a plus b t. So we can now find the formula of b, or we can now find the value of b by um, plugging in those values that we found from our table. So n, again we must follow the b formula, equals n summation of ty minus e in minus summation of t summation y over n summation t squared minus quantity of summation t squared. So to plug in those values, so n, since we have with 5, S is 5 data in here, so that is the value of n. 5 and then summation of ty in our value. So it is summation of ty. So here. So we must plug in and then minus summation of t, which is 15, and summation of y, 812. So times. So just plug in those numbers so we can come up with 12,495 minus 12,180 over 275 minus 225. So to add or to calculate, we will come up with 315 over 50, and that is we can have our B right now, which is 6.3. So next, since we have already the value of B, we must now find the value of A to complete the formula. So to find A, so that this is our formula again, E summation of Y minus B summation T over N. So summation of Y, again, that is 812 minus B, which is the 6.3. We can plug in right now the B, 6.3 times summation of T, which is 15 over N, which is 5. So to calculate 812 minus 94.5 over 5, that would be 717.5 over 5. So we have now the value of A, which is 143.5. So to complete for the formula, y equals a plus b and t. So we have to plug in the values what we have found from the based on the formula. So y equals a, which is 143.5 plus b 6.3, and the time t. Suppose we are to find, so this is the t, that is also the example of our independent variable, or let's just say the week. Suppose we must find the value, or we must predict for the future, which is week 10. So we to find for the week 10 formula, so we must just follow the formula in here. So y sub 10, meaning we are finding the week 10 in our formula, plugging in the values, time with 10, and then that would be equal, so week 10 is equal to 206.5, or approximately 207. So that would be all for the example. By the way, this example is only about the forecasting using the time series and linear regression. And also, maybe you'll have a doubt if ever in the formula there is an error. So just to say, the error that is a residual, and we can find error in the formula. So the formula of error, that is what we predict and minus the actual. So since this is on we can also find that easily when we are using a software. We do have a software tool that is an automation. Once we have the data completed on that, we can also find for the actual value. Once we are on the week 10, we have the value of week 10 already, and then we can have the predict value minus the actual data on the given data set. So that will be an error. So that would be not necessary for this example, because this is assuming only that we have already completed criteria based on those assumptions from what the previous reporter said about the um, when will we use the linear regression model, how will we fit the time series in the linear regression model. So this is part of the this example is only for example for the linear regression using the or solving the time series by fitting in the linear regression model. And that would be all for our topic time series. And thank you so much for listening. Have a blessed day. Thank you.